Hello, my name is Donald O'Hare, and this is my lab report for Lab 1. In this lab, we recorded and tracked the system of a dry erase marker over time using Tracker, and the system was in motion due to being struck by my finger, and we assumed that it was moving at a constant speed due to the constraints of the lab. We used the Tracker data to then calculate the average velocity over the entire period, and the X position of both the actual pen and a glow script prediction based on the Tracker data were modeled with respect to time, yielding actual and expected position graphs. Both had very similar data points with a few differences that can be accounted for. A portion of the motion over 1.5 seconds was analyzed, and due to the assumptions of the lab, we assumed that since it was at a constant speed, it was in dynamic equilibrium, so there was zero net force on the system of the pen. And the starting point was set at the origin, and it moved solely in the positive x direction to the right. So we assumed that the speed would equal the velocity in this case, in the x direction. And slight movement in the z and y axis was ignored for this experiment. And if the x-axis were to be flipped, the pen would be tracked as moving in the negative x direction, which would just result in the position graph flipped along the y-axis. And it was tracked by hand, which introduces human error. And since we assume that the speed was constant, we can also assume that the velocity is constant, as it is only moving along the x-axis, like I said before, and it's in dynamic equilibrium. And going forward, velocity and position are only going to be referring to the x component of the pen, since this experiment was only in that axis, but there is still motion in the technically z-axis, because the y-axis would be up and down because of gravity. But so we calculated the average velocity over 0.0116 centimeters to 25.93 centimeters over 1.467 seconds, which came out to 17.60 centimeters per second. We then assumed that this was the instantaneous velocity of the pen at any given point, since the speed was assumed to be constant. And then put this velocity value into the GlowScript shell, and this utilized a while loop to iteratively calculate the new position every 0.01 seconds. And it used the position update formula for constant velocity motion with 17.60 centimeters per second to calculate the expected position and plot the data over 1.5 seconds, just like Tracker. And these are the screenshots of that, and these are them graphed out. So as you can see, they have very similar paths, but there are some slight differences. So both were increasing, had just about the same starting and ending points. And the biggest difference between at any given time point was about 3 centimeters at 0.53 seconds. So overall, GlowScript was able to model the real motion of the pen with relatively high accuracy. So differences can be accounted for by a few reasons. First, like aforementioned human error in the tracking, and the assumptions made at the ending of the lab, which were that the speed of the pen would be constant. But it is, as we know, not constant because the net force acting on it is non-zero. It has the normal force, friction, and gravity acting on the system, which is going to slowly decrease the speed over time, which we could see in just the motion of the pen itself. It would eventually slow down and stop. But despite this, the net force is relatively small despite being non-zero, and therefore not acting on that initial speed very strongly, which allows us the freedom to use this model in GlowScript to predict the motion with relatively high accuracy over this short time period. These findings can lead us to a few conclusions. First of all, it shows us that over short periods of time, we are allowed a lot more leeway with our calculations and assumptions, especially when there's a relatively small net force acting on the system, because there's not a lot of time and force to change the velocity and position of the system. And assuming constant speed is a valid technique in situations like this one, and it drastically simplifies our calculations while still returning a similar result and making it possible. And finally, it shows us the importance of technology, as Tracker was essential for actually getting the data points, and the GlowScript code allowed us to make hundreds of calculations in the blink of an eye, which would have taken hours by hand and been less accurate. Thank you.